Good afternoon. Today I will discuss about the topic that is minimum spanning tree. So before starting that, I'll tell you about what is spanning tree. I have taken the definition here. If G is a graph having set of vertices V and the set of edges E, so any subgraph G dash that is derivable from that graph G will be called as the spanning tree if and only if G dash is a tree. Now you will be thinking that how can we determine that a subgraph is a tree or not? So for this we know that a tree is having the property that it does not contain any cycle. So any subgraph which will be having cycle cannot be a spanning tree, and any other subgraph which does not contain cycle can be a spanning tree, right? So I'll explain you in more detail through this example. See, I have taken a graph with the vertices A, B, C, D and the 6 edges. Now I'll show you the number of possible spanning trees that can be made out of it. So I have drawn the first subgraph here with the vertices A, B, C, D but only 3 edges, that is AB, AC and BD. Now you will find that if I include one more edge, suppose I take CD edge, then it will create a cycle, right? If I'll take BC edge, then it will again create a cycle. If I'll take ATH, then it will again create a cycle. So I have taken that subgraph that will not make a cycle, right? See second example. Here I have taken edges only AC, BC and CD. Likewise here also, if I include BD edge or AB edge or AD edge, then the inclusion of single of these edges will create a cycle. Similarly, in the third example, the inclusion of AC edge or BC edge or AD edge will create a cycle. So these are the three possible spanning trees that can be made out of the graph, that is G. So now we will talk about minimum spanning tree. We all know that the cost of the subgraph is the sum of the weight of the edges of that graph. Likewise, if I want to find out the minimum spanning tree, then I have to find that spanning tree that is having minimum cost. Means if a graph is having n number of subgraphs, then I'll see which subgraph is following the property of spanning tree, plus it must not contain a cycle, and also the weight of the edges of that graph must be minimal, right? So I'll take this example. See, I have taken a graph ABCD with the weight embedded on the edges of the graphs, right? Now I'll show you the possible spanning trees that can be made out of this graph. See, I have taken this example. It is a subgraph A, B, C, D with only 3 edges of weight 4, 2 and 5. Because if I'll take AB edge, then it will be a cycle. Likewise, so its cost will be 11. Similarly, second one, I have also taken a subgraph and its cost is 7. Right? So I can say that between the two possible candidates for spanning tree, the second one is having the cost 7, that is 4 plus 1 plus 2, that is minimum than the first one which is having the cost 5 plus 4 plus 2. So second one is my spanning tree. I hope this topic will be understandable to you. Thank you.